Good evening, everybody. My name is Guillermo Herrera, as already mentioned, originally from Guatemala, and among the many things that I have done in my life, one of the most interesting ones is that I train as a disease detective, and my work was to respond, investigate, and solve outbreaks around the world. So, and that means that I had to interrogate, be curious, look at different sources of data, figure out where, how, why things were happening, and then give a solution so that the outbreak could be controlled. Out of that training, out of that thinking, I decided that the best way to approach life is to always aim at the impossible, to be able to reach what is possible. So always be a dreamer. Never forget about dreaming, because out of dreams, great things will come. Better society, a better world, and hopefully as well, in the process, better human beings. That will be beautiful, I think. So when I prepare my talk, well, first of all, I'm jet lagged. And when I'm jet lagged, I have thoughts that then I forget, but it's good that some people record them and figure out what is that I just said. I actually probably I had to ask him to write it down so I can put it in the next project, but anyway. So I would have really prepared a different talk had I seen you before. But let's do a mix of this one. So let me start by saying that you hear a lot about Zika more than dengue, and you worry about Zika more than dengue, the same family. They are cousins. Sometimes I think they are brothers. There's not much difference when you look at the genetic tree and the separation between one and the other. The 4 serotypes of dengue and Zika could be the 5th serotype of dengue. There is even a study and speculation that says that when you develop antibodies to dengue, you enhance when you have a response to Zika and an infection to Zika. And that's why we saw what we saw in Brazil and the microcephaly, etc. So one of the things that I like to do is not out of curiosity, it's just that I get really energized when things are happening. So I'm always in the web looking at ProMed, FluNet, all of the different areas where you can find ways that disease is spreading or going or not going, and finding nodes of extinction or nodes of expansion. So I'm trying to figure out what is happening there. So what's going on here? So to give you an example, about some 6 months before Zika started to be what it was, we started looking ProMed. There is a problem going on in Brazil, in northern Brazil. There's a problem in terms of the increase of mosquitoes, the Aedes aegypti. There is a problem. We are seeing more cases of microcephaly, but not just microcephaly. There is a problem with this specific type of microcephaly that has specific characteristics that we haven't seen or we don't see that commonly. And then they started to say, and we have clusters of Guillain-Barré. And I say, wow. So we have microcephaly. Now we have Guillain-Barré. There's something completely different. What else is happening there? There is Zika, a new virus that was introduced. So when you put the things together, you go and say, we have to pay attention to this. One of the issues is when you start too early. We say in Spanish, you can never be a fortune teller unless you have an audience to know about what you are talking about. So most of the people don't understand what are the dynamics of going on. So they dismiss what was going on. The same way, for example, what happened with the Ebola outbreak. When it just started and people started to send messages and say, something wrong is going here. This is going out of control. Please WHO pay attention. Nothing of that happened, and it exploded. And then people started to think about Ebola or something that happens, like transmission can happen by chance or etc. And the first thing that you know about Ebola when you have worked with Ebola is that you need to touch the person, especially when it's at the last days, the 2 days of the disease is going to die, or after the person dies. There's no transmission other way. It's very difficult. So if you understand that, then you understand how is that Ebola is transmitted. You follow the chains of transmission, etc., etc., etc. So if you understand or try to understand Zika, and I'm sure you have heard, work, and look about, and I'm not doing anything about my presentation, sorry about that, but but the thing that you have to think is, okay, it's the same family of viruses. The second one, it's the same mosquito. So whatever you do about trying to figure out the mosquito, you do to trying to figure out Zika, and you try to figure out dengue. Whatever contribution you do for dengue, you do for Zika. As simple as that. If that is not enough impulse for you to work into dengue, I don't know what else. But anyway, so yes, we have the Aedes aegypti, and we have the Aedes albopictus. Aedes aegypti is a warm climate. It's really good at reproducing at 20 centigrade and above. The reproduction cycles then get extended, takes more time if it is below 20 centigrade. If it is below 15 centigrade, then it goes kind of doesn't want to have sex, so it goes less. If it is less than 15 and 10, less than 10, then it goes down. It's not there. But there is Aedes albopictus. What happens with Aedes albopictus? That guy goes to sleep, hibernates. So where do we have Aedes albopictus? All over Europe, all over the US. And what is Aedes albopictus being able to transmit? Dengue, Zika. So yeah, the possibility is there. The reason why it's not really there is because we still have some cold climate, winters, and it's a developed society, etc., 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 that makes it more difficult to come. But you can have outbreaks, the same that we have in the US. We have seasonal outbreaks, rainy season comes, and this is also something very important in understanding. So we have the vector. We have conditions for that vector to be there, which are temperature. Which other one? Rain. But it needs the right amount of rain. When rain comes, and is the peak of the rainy season, it washes. Dengue likes clean water, small pools of water. That's where it develops the best. So if you have a heavy rainy season during the monsoon, there is not much in terms of transmission. But when is it gone, before and after, there is transmission. There is increase in the dengue population, in the mosquito population. So it's important to understand also where the mosquito is, why the mosquito is in there, when is it increasing, why is it increasing, what can we do to stop that increase, where does it go, and when it's a lot of rain, then it washes out. And then rain decreases, then it comes again. So it needs the rain. It needs the host, it needs the human being for the dengue to be able to infect the human being and for us to be able to infect the mosquito and continue the cycle. And it has to be, sorry about that, but I don't know why in nature it's the female that transmits. It's I don't know. Anyway, I can't speculate about that. So, and the mosquito has another characteristic that is likes to bite early morning and late afternoon, not when it's night. So it's different from malaria. So now every time I go and something bites me, the first thing that I do is slap it, and then I look at it and say, okay, this is albopictus, no, this is Aedes aegypti, and then where is that I am and what season I am, and am I getting in trouble here? No. Okay, so you have to be curious about that. You have to be curious about what is going on around in your community. That's part of the disease training in terms of finding out what's going on in the community. But there is more than that. There is transit. There is issues related to what is the socioeconomic status of the people there. Can we find hot spots for dengue transmission? What are those hot spots? Dengue, when you look at it, it comes back and again to the same communities. Why? And when you go to those communities, low socioeconomic, low education, lots of containers around, then they develop this is population that is susceptible. Among the rich people, because they have screens in their homes, or they have air conditioning, they have their gardeners and they are not tending to the gardens, then you don't see that much dengue in those wealthy communities. But in the slums of the different countries, you see dengue every year. And those are the areas that we can intervene and do something about it. So any solution as well that involves a human being involves treating that human being as a human being, involves economic development, involves looking at education, involves of empowering the communities, involves in terms of looking at what else we can do to bring the status of those human beings higher and higher and higher. That's the best way to fight disease, actually, more than anything else. And if you think in terms of development and how we have improved health through the years, hasn't been because of the big brains that created the new vaccines, the new antivirals, the new drugs, etc., has been economic development. So that's part of also understanding the disease dynamics and what we can do with those communities, etc. Otherwise, we will continue going back and back and back and back and back to the same problem. So if we really want to solve the problem, we have to work together and we have to consider everybody else as we are human beings, more than anything else. So we have those conditions in terms of, do you have a question? Sorry.
Yeah, I think most of us probably are not biologists, so I was hoping you could explain the life cycle of the dengue virus. And you mentioned 2 types of mosquitoes. Are those the only types of mosquitoes that transmit it?
Yes, for dengue is the only 2 types of mosquito. For Zika, they are studying if there are other mosquitoes that are transmitting, but not really. So let me, where is this? If I move, okay. You see, I went all over the place and I haven't given my, but I thought about something else. So one of the difficulties about the dengue is that one, it is the human being, but also it can transmit to other species like primates. And so it has a sylvatic phase as well. So in places like Southeast Asia and Africa, because it stays as well with the sylvatic phase, there is a constant circulation in terms of you can, in a way, eliminate dengue, but comes back because continue infecting all other, in this case, sylvatic elements. In Latin America, for example, the American continent, it was possible to eliminate the Aedes aegypti, the Aedes albopictus. It was possible to have dengue-free periods. We don't have that sylvatic phase in the American continent because it needs the type of of more evolved type of primates that you have in Africa, that you have in Southeast Asia. So we don't have that. That's the first thing in those areas. So it's easier to have free periods of dengue or completely eliminate in areas like Latin America. Cuba has periods that goes from years without dengue. It's an island, different system, more educated population. They have equality in access to healthcare. I'm not going to talk about politics, but that makes Cuba a perfect example of what can be achieved when people are thinking and working together. So they are able to eliminate dengue and get dengue-free years. But then again, comes back because it comes from the other communities. So there are, also dengue is not only infecting the primates. When we are in the communities, the other thing that we have to pay attention is that dengue can also, when they don't have easy access to human beings, dengue will also bite and infect the dogs, the cats, the goats, etc. So that's another thing that is important in controlling dengue. So it's not only the human interface, it's also the animal interface, where they are in the community, etc. Let me see, to go back, I guess this one. Let me see. So thinking about what you ask in terms of what else I would say more than because it's important to understand the mosquito. So the mosquito is that the mosquito transmits dengue, yellow fever, West Nile virus, transmit Zika. Then is the pregnant females likes to bite during the day. When Zika was discovered in the Zika forest in Uganda in 1957, one of the things that the scientific working with in that forest said is that the mosquito, the Aedes, it's so pertinent. I mean, it keeps coming and coming and trying to bite, and it's impossible to get rid of that mosquito that is trying to bite. If you go to Latin America, if I go to Guatemala, where I am from, and one of the things that I always notice is that during the day, I'm sitting somewhere, and the mosquito, and it's not one mosquito, you hear the, and then they come, and you move, and swap, and you say, I better walk. You cannot stand still, because otherwise they are going to eat you alive. So they are very hungry about that. Well, to recognize this, if you are curious, I mean, you always see in the Aedes aegypti, at least in the tiger mosquito, you see the nice stripes. So that's the other thing that I like to do. I say, figure out, is it? Oh, yeah, it is. It's because those containers, those areas, and the human beings that they like to bite and infect, etc., are in urban areas. That's the place where they like, in the slums. And what we talk about, the shallow water surfaces. So the other thing that is important to understand in this cycle of dengue transmission oh yeah, that as you can see, the mosquito can bite, and then different from other viruses is that once you have you reach viral peak, the fever can start. But once the fever starts, the symptoms start, you are already at the peak of the viral load. Then it starts to go down, and it has a period of almost 3 to 4 days. And once the fever is really going down, that's the critical phase when we have the worst case of dengue, which is the hemorrhagic dengue. That's the one that can kill you. That's the one that has the extravasation, the accumulation of liquids outside of your arteries, veins, etc. That's the one that can produce the hemorrhages and all of the problems that you see with hemorrhagic dengue. So the people at risk of dengue in the world is 4 billion people. People dying every year of dengue is between 15 and 22,000 people a year. It's not that high if we consider what other diseases cause, but in terms of economic terms, it's about $5 billion that are spent in trying to deal with the situation with dengue. Also, when you have dengue, it's not like having anything else. I mean, it's called the, I know the word in Spanish, but in English, break-bone fever. It's one of the things that, one of the delights of being studying and trying to control outbreaks is that you can always come with one, I call what, with a friend back. Is it a parasite? Is it an infection? Is it dengue? Or is malaria? Or is cholera? I have them all. So sometimes I don't want to go anymore to the field because I wonder what the hell am I going to get back with. But then that period is the one that can really kill you, and it's once you have in that decrease in the viral load and that decrease in terms of the fever is when you start getting the positives for the antibodies and you can do the diagnosis, etc. So that's one of the difficulties on dengue. So the difficulty is that once you start with that critical phase, the time to act is very small. So the time to intervene is about 24 hours. No more than 48 hours to give any treatment for those cases of severe dengue, hemorrhagic dengue. So that's the difficulty of that one. Yes?
So if someone survives, are they okay after that?
That's the other, yeah, in terms of sequela, they are okay after that. unless they have some severe dengue has caused hemorrhagic in the brain, etc., they will have something. But in terms of being able to recoup and have a normal life, yes. Does that infection give you protection for the next infection? No.
And you don't pass it on? You can't pass it on?
No, it's not like Zika. Yeah. Zika, you can pass it by sexual transmission, etc. You can pass it to the mosquitoes. So when you are asymptomatic with dengue, you can pass the transmission. You can be bitten by mosquitoes that will get the infection and will be able to transmit the infection to other human beings.
Mother to child?
No mother to child. Not that I know. I will have to look because Zika transmits from mother to child. So I have to look at that one. So where were we? Then let me see. There's another interesting thing that you may be willing to take into dengue. Well, look at this. So at the center of everything, if we get rid of the mosquito, we get rid of dengue, Zika, West Nile virus, etc., yellow fever. But it's difficult to do that. Because they also get resistance to the pesticides that we have employed with DDT. That's the one that was key in getting the continent of America almost free of dengue, free of mosquitoes in the 70s, etc. The problem is that we always were getting rid of also our newborns and animals, and the rest of we were intoxicating everyone in the community. So DDT was stopped. Mosquito went up, then the transmission epidemic started in the 70s, 80s especially, and then in the 90s exploded, and we have dengue almost everywhere in the Americas, with the exception of certain areas, like Chile. Will you try to speculate why there's no dengue in Chile?
Temperature, altitude, no mosquitoes.
Yes, there are mosquitoes. But altitude. So if you see a Chile, it has two barriers. One to the north, the Atacama Desert. When you see rain in the Atacama Desert, it's an incredible happening. I mean, it rains every 20 years, whatever. And the only rain that I saw in the Atacama Desert, I thought it was raining, it was just a dust storm. So you don't want to be in the middle of that one. The other one is the Andes. So sealed completely, and altitudes of 5,000 to 6,000 meters, so we cannot go there. And the other one is to the very south, temperature, so we cannot survive in there. So we don't see that there. Another country where we didn't see dengue until this year, Uruguay. Why? Because Uruguay is very south, it has a winter, mosquitoes die, but they have had 2 warm winters. So the temperature stayed at 15 for 2 winters, and we already had dengue introduction in Paraguay, bordering Uruguay, in 2012. So it was coming down, waiting for a warm winter to be able to survive. So that happened. Then the population in Uruguay, when traveling, they always travel, especially in the winter. They go to other areas, they go to the Caribbean, they go to areas where there is dengue transmission, etc. They came back to Uruguay, they found a mosquito, and we have the first outbreak of dengue in Uruguay. But is that outbreak in the slums of Uruguay? No. It's in the richest neighborhood of Uruguay, because they had the money to travel, and the mosquito was everywhere. They will find larvae of mosquito everywhere in the gardens of the people of that richest neighborhood in Uruguay. So that's why it came into being. If they have and haven't checked the temperature for this year in Uruguay, but if they had a really cold winter, then no problem. But if they had another warm winter, then it can stay there. Remember Argentina, it didn't see dengue as well for a while, but in the last 2 years has had major outbreaks, first in the north, bordering the Paraguay, and now it's in Buenos Aires, Argentina as well. So all of that plays into, so the question for me is the same question that I had with, everybody probably here has worked with influenza. So is there any genetic change? Is there any accumulation of genetic change? Is there a drift in terms of that genetic variation in the dengue? So we have 4 serotypes, the same as we have 4 influenza strains. Can there be that at one point one of the dengue serotypes becomes dominant and then provokes this big cycle? For example, right now, Thailand, Myanmar, they have a big epidemic that goes back to the 80s, the highest transmission and incidence and mortality, etc., that they had seen in a while. There is a new serotype 3 that is circulating. The question, and I haven't been able to find that information, which is so important. What is the genetic tree of that one? Has there been any variation? Is there anything that is accumulating there that we need to figure that out? Can we deal with dengue the same way we deal with influenza? Can we do cartographic analysis of that? Can we understand better by looking at what is the genetic tree and how it's varying in different areas? What is happening with that tree? And can we really tell where that new serotype 3 is going and where it started? It seems that it started 2 years ago in Fiji. Fiji is really famous for these big ones. It's a good place to go and study dengue, but the problem is that it has dengue and then it has nothing. And then it has dengue again and it has nothing. So probably the best time is when it has nothing and you can spend the time saying that you are doing research, but really having a good time. So, so those are the questions that we have about dengue. So how is that this is going from places to places? You can follow dengue in terms of the strength of the spread in Central America. That's the place that I know the best, by following the rains. So when it's starting, you know that the mosquito is increasing, and then you see kind of coming up until it gets to you. The other thing is that we have high and low altitudes. So we didn't used to see dengue in Guatemala City. We didn't used to see dengue in Cuernavaca, Mexico. Those are 1,500 meters. But global warming, I hope everybody believes in global warming. If not, then we can talk. But anyway, so the issue is we are having warmer and warmer climate. Mosquito is able to, before we didn't find mosquitoes above 1,300. Now we have mosquitoes in Guatemala City. It's seasonal because the temperature can drop in Guatemala City to 10 centigrade or less, 9 centigrade or 8 centigrade. So the mosquito is no longer there. But when it starts warm again and rain, then we have seasonal dengue. We have outbreaks. So, and that's the other issue. How can we predict? How can we tell? How can we then intervene at the right time so that we can stop the outbreak from happening? So in seasonal dengue, there is a possibility of combining strategies, vector control, antivirals, the vaccine that is out, to at least stop those outbreaks and really seeing free dengue in seasonal dengue. Hyperepidemic areas like Thailand, like Southeast Asia, is a different issue. So how is that it starts? How is that it spreads? How is that it comes from Myanmar to Thailand? Where does it go from there? What is the genetic variation? What is the interaction with the mosquito? What is happening with the mosquito? What is happening with that population, etc.? All of those are the situations, and all of that I know is the reason, or one of the reasons why you are so interested in looking at this disease. So it's a different layers in terms of what we have to look, from the mosquito to the animals to the human being to the socioeconomics to the geography to the temperature to the rain. That is dengue. And if you solve and do good things about dengue, be sure that you're doing the same for Zika. If that is not enough in terms of lifting your spirits, I don't know what it is. Get the infection yourself and then you will do something about it. I don't know, I don't want to continue talking. Yes, it's probably not the time to give all the things about dengue. I just wanted to give you the sense of what could be there, or what I can see when I see your eyes and when you see the presence. I see a gold mine. Yeah, I see possibilities. And I'm grateful that you are willing to take the time to entertain these ideas. So I think that's it.